Hello everyone, and I would like to welcome today. This is the 9th Global Conference on Consumer Electronics to be hosted in Kobe. My name is Jojo Kai. I am a student from University of Computer Studies, Yangon, Myanmar. Today, I would like to present the title Expedition of Rainfall based on Deep Learning and Internet of Things to prevent landslide. Now, I present the outlines. Abstract, the next session, introduction, the next theme, system architecture, in the next session, prediction, rainfall model, and next, forecast and varieties, time series, and result and conclusion. Now, I present the abstract. Rainfall data is very important for the disaster, that is, people and their property loss. Myanmar has two hilly regions. They are the western region and the eastern region. They have both landslide and also chain state areas and chain mine areas in Kachin state. Orange, you can see a lot of landslide. This model with the Internet of Things system can predict the landslide. This system has a soil moisture sensor, weather sensor, Raspberry Pi 3B, and send the message and data to rural areas, mountainous areas, government and non-government organizations. Soil moisture and precipitation data are mainly for a landslide event. This information may change dynamically from the soil layer and due to the heavy rain. Moisture sensors are deploying in the soils and scale monitoring moisture. Landslide is due to heavy rainfall. The prediction is depending on the soil moisture. Precipitation really depends on its load. We have to know the precipitation, how much, and rainfall data. This system forecast and variety time series approved with baseline method regarding now long short-term memory model with deep learning using the daily rainfall data. This system is low-cost and real-time monitoring system. I would like to present the introduction. Landslides are loss of human life in mountain region, river region, and seeking provenance in Myanmar. To reduce the losses, requirement for national monitoring system for landslide on the hilly regions, they don't have any plans. Moisture sickness and rainfall data are provided when alarm or signal before the occurrence of landslide. This system intends to get information on time and to prepare according to decrease the damage and the harm of life. IoT and artificial intelligence AI convergent the information and communication technology in fourth industry revolution. IoT embedded with software sensors and network connectivity. It collects the data easy and exchange the data. Now IoT global cloud service providers have developed. Now I want to present the Raspberry Pi 3. It's a small board. It has 4 USB ports, can easily plug a keyboard and mouse. It has high definition multimedia interface video output. It uses a SD card instead of hard disk that is useful for storing the OS, and Pi is term for Python interpreter. It can learn programs easily. Third generation models have Wi-Fi and Bluetooth. Pi Wi-Fi is just a payboard which has no case to protect it. Inside these are general purpose input-output pins, and they allow Raspberry Pi 3 to be connected to custom electronics. It also integrated Wi-Fi and Bluetooth. I would like to talk MCB 3008 analog digital converter. It's a low-cost 8-channel 10-bit converter similar to Arduino Uno, and with 8 channels you can read quite a few analog signals from Pi. This is a great option if you just need to read simple analog signal, like from temperature or light sensors. Why we need an ADC? Because Pi computer doesn't have a way to read analog inputs. Analog inputs are handy because many sensors are analog outputs, so we need a way to make Pi analog friendly. This ADC acts like a bridge between digital and analog. Although this sensor provides a digital pin that can send a signal as soon as threshold is exceeded, now I would like to present the soil moisture sensor. It measures the volumetric water content in soil. The direct measurement of soil moisture requires drying and weight is simple. It measures the volumetric water content using the property of soil moisture that are electrically resistant, dielectric constant, or interaction with neutrons for the moisture content. Now I would like to present the weather sensor. It's the monitoring station sent to display weather data from Pi 3 connected by USB port. It can measure temperature, rainfall data, humidity, wind direction, and wind speed. Now I would like to turn to present the system architecture. It includes light embedded device, soil moisture sensor, weight module, Pi 3 collect the sensor data. Rainfall data, humidity, temperature data get from professional weather sensor in outdoor. Using the rainfall time series data and deep learning model. This is my study area. It's located south region of Myanmar. It is between the longitudes 97 degree 32 minute east and 97 degree 33 minute east, and between the latitudes 60 degree 27 minute north and 60 degree 32 minute north. Now I would like to move a prediction rainfall model. Real-time monitoring system monitor data continuously, generate the various amount of data package from analysis. This system generates the historical data from the Thong District 2019 rainfall time series data, Mon State, Myanmar, and construct the recurrent neural network Recurrent neural network is a type of neural network where suited to time series data. It's especially a long short-term memory model with using the time series rainfall data. Daily sensor values are being used by models and predict the future rainfall trend. These predict data when over the threshold value. These sensor threshold values are over 70 mm trend line up. Sent to Landslide warning message. This message will be sent by using low power wide area network-based relay network. This network also be important for data to send rural or mountain areas that are very far from town can be sent destination because my contribution is local system. Now I would like to present the forecast of varieties time series. This graph shows the rainfall data 2019 history data and another graph illustrates the history versus true future. The information given to the network is given in blue and it must predict the value at the red cross. This graph illustrates the baseline prediction model. Now I would like to turn to result. Soil moisture contents change according to the thermodynamics data of the soil and the water cycle of the ground surface, affected by heavy rain. In the process of soil moisture value change, various value and the effect of rainfall data and soil moisture value has important influence on land temperature change. Soil moisture value is also relating the precipitation and cause to landslide events. Due to the rainfall greater than 70 mm, soil moisture data and weather pressure data, water pressure data change with slope angle. In my lab, similar to static area, have identified the threshold value for land levels or rainfall-based changing factor. Professional weather sensor can get parameters such as precipitation, humidity, and temperature could be installed in the algorithm and during artificial rainfall. The variation in the slope can be steady and based on that the database will be created in the landslide monitoring site. It can be used to identify the landslide hazards prone zone areas that depend on the landslide chain, distance from roads, distance from railways, distance from stream, dam, and slope angle, slope aspect, soil type, and rainfall data. Now I would like to show the simple LSTM model is better than baseline model. How can we use this to our benefit? This conclude the deep learning model based on time series data. History rainfall data based on deep learning and IoT can predict the future trend. This system is used for real-world and rural area. It used locals and predict nearly real-time rainfall data. It can protect the life of people near landslide-prone areas. Thank you so much for your interest and attention. If anyone would like more information or has questions, please feel free to contact me at my mail.